Right. So let us solve some example problems that are based on the polynomial the basic ideas that we studied in the previous video. Now the question here is, which of the following expressions are polynomials in one variable and which are not, and we have to explain. So let us look at the examples. The first one is 4x squared minus 3x plus 7, right? So the only thing we have to see whether if it is a polynomial in one variable is just to check the number of variables in the expression. Now if I look at this expression, the only variable that it has is x, right? So you have 4x squared minus 3x plus 7. So this is a polynomial in one variable. So the answer to that is yes. The second problem is y squared plus square root of 2. Again, in this case, there is just one variable, which is y, right? And therefore, it is also a polynomial in one variable. Now let us look at third example. The third example is 3 square root of t plus t square root of 2, right? So in this case, as you can see that there is just one variable, right? So we have t and t over here in both the terms, but there is another important aspect that we need to know, that this expression has to satisfy to be called as a polynomial, and that is the power to the variable must be a whole number. Now if I look at the second term, right, the power to the variable is 1, t to the power 1, but when we look at the first variable, it is actually 3 multiplied by t to the power 1/2. That's what the square root can be written as, right? Plus t square multiplied by square root of 2. So because this the variable t is raised to a non-whole number, right? Therefore, it's raised to a fraction. So we cannot call it as a polynomial. So it is not a polynomial, okay, in one way. So it's not it's a polynomial in one variable. I mean, it's an algebraic expression, but I wouldn't say that it is a polynomial in it's not a polynomial basically. Yeah. Now if we look at the fourth example, right, we have y plus 2 to the power y. Again, this polynomial certainly has one, I mean this algebraic expression has one variable, but if you look at y plus 2y can be made to the power, so it's not actually a polynomial, right? Even though it's an algebraic expression in one variable, so I cannot call it as a polynomial at all, right? So it's not even a polynomial, even though it's an algebraic expression in one variable, but not a polynomial in one variable. And we look at the fifth example. Let's say x to the power 10 plus y cube plus t to the power 50. Now this is an interesting example because if you look at the number of variables, you have 3 variables, x, y, and t, right? So this is a polynomial, right? But it is a polynomial in 3 variables because there are 3 different types of variables. So this is also not a polynomial in one variable.